I want to start my short introductory talk about the Lorentz transformation and about simple derivation of the Lorentz transformation first. As we know, it is taught in the undergraduate physics or even lower in some extremely high level scientific high schools, but let me start. Okay, so how we derive the Lorentz transformation in a very simple way. I forgot that I am this beautiful place in Füssen, Germany, today near Neuschwanstein castle, and I am recording from here. And okay, so first what we do is we take the two coordinate systems, and the time equals 0. They are the origins of them are at the same place, and what we do is we consider the photon emitted from the coordinate system between we are at rest, and this photon is chasing the other coordinate system which is escaping velocity v. So we want only that the speed of light is invariant in both coordinate systems. So you write the equation that c times t prime in a moving coordinate system is equal c minus v times t in the rest in the coordinate system we are at rest. From this we are getting the simplified transformation that is the x transformation is Galilean, and it is x prime equal x minus vt, and the time is if you find out, if we will find out that the if c minus v times t is equal c t prime, then t prime is equal to 1 minus v over c times t, and we can now write the v over c times t as x in terms of x, and we have that t prime is equal t minus x v over c squared. Okay, so we have simplified. Now we solve the linear system of equations for t. We have transformation t prime as a function of t, and we have the transformation for t prime x prime as a function of x and t. And now we reverse, we solve the linear system of equation. We find that t is equal t plus v over c squared times t prime divided by 1 minus v squared over c squared, and so x prime is equal v is equal x is equal x prime plus v times t divided by 1 minus v squared over c squared. So we see that something is wrong because the original transformation did not have the denominator 1 minus v squared over c squared. So what we do, we want to improve the transformation now, the original one, and we multiply by the factor kappa, the right side by factor kappa, and we see that the reverse transformation has immediately 1 over kappa, and now we must have 1 over 1 minus v squared over c squared times 1 over kappa equals to kappa, and then kappa squared is equal 1 over 1 minus v squared over c squared. Therefore kappa is known gamma 1 over square root of 1 minus v squared over c squared. So we get the final transformation that t prime is equal t minus v over c squared times x divided by square root of 1 minus v squared over c squared, and we get now that x prime is equal x minus v times t divided by also square root over 1 minus v squared over c squared. So we derive the original known Lorentz transformation from the requirement that if we scale the simplified transformation, the scaling factor turns out to be gamma non-flow Lorentz transformation, because we want that if we there is absolutely no difference in the transformation equations except the velocity sign when we are in frame x, and the frame x prime is moving, or we are in frame x prime, and then we see the frame x is moving velocity minus v. So this is how we derive it in very simple way. Okay, thanks.